Welcome to paper 2 of the June 2017 series from Edexcel Higher Tier Maths. So here we are. So paper 1's happened, that's non-calculator. This one here is a calculator paper. I'll show you a few methods for some questions, just one method for others, although bear in mind there are numerous ways for pretty much every single question. So if your way is different to my way yet generates the correct solution, you can probably assume your method is correct, but if in doubt, please do check with me or your teacher. So let's have a look straight away at question number 1. So here we've got a table showing probabilities a biased dice will land on a 2, 3, 4, 5 or a 6. So Neymar, a football reference there no doubt, he rolls the biased dice 200 times. The dice is biased because the probabilities aren't the same for each side. There should be 1/6 if it were unbiased, but these are slightly different probabilities, so this dice is not fair, it's biased. Work out an estimate for the total number of times the dice will land on a 1 or a 3. So we don't really care about a 2, 3, sorry, don't care about 2, 4, 5, 6. We just want the probability of landing on a 1, which is this probability here we need to work out, or a 3, which is this one which has been worked out. So what we need to know for any one event is the sum of all the probabilities add up to 1. So going at this number here, by adding together all of these, and then taking this away from 1. So if we add all these together first of all, we can see what that gives us. So first off, we've got 0.17, then plus 0.18, then plus 0.09, plus 0.15, plus 0.1. That gives a total of 0.69. Therefore, the probability of landing on a 1 will be 1 subtract 0.69, which will be 0.31. So probability of it landing on a 1 or 3, so probability of a 1 or a 3, that's a probability of landing on a 1, and or works as add. So it's probability of 1 plus the probability it lands on a 3. So the probability it lands on a 1 we have here is 0.31, so this one here is 0.31. Plus the chance it lands on a 3, and the probability it lands on a 3 is 0.18. So the total overall probability of landing on a 1 or a 3 is 0.31 plus 0.18, which gives 0.49. So think of that as being 49%. So it'll land on a 1 or 3 49% of the time. So therefore the expected number of 1s or 3s, the expected number of 1s and 3s, well, having 200 rolls, and we'd expect 49% of those 200 rolls will give us a 1 or a 3. So it's going to be 49%, or just 0.49, multiplied by the number of trials, which just means the number of rolls. So we do that on a calculator, we should find that's 0.98. So 0.49 multiplied by 200 gives us, sorry, 98 I mean to say. So that's our final answer. So we've done question 1, we're off and running, we've broken the 0, we've got some marks. Let's have a look at the next question. So question 2, we've got this question here which is a bit of a problem solving one. We've got a mixture of a ratio and a fraction and all sorts, and a percentage too. So what we're told here is that on Saturday some adults and some children were in a theatre. The ratio of number of adults to number of children was 5 to 2. So that means that for every 5 adults there must have been 2 children. Each person had a seat in either the circle or in the stall. Now, first of all, what we're told here is that 3/4 of the children had seats in stalls. Now, all the people were either in the circle or the stalls. So if 3/4 of these children were in the stalls, that means that 1/4 of them, the other remaining quarter, must have been in the circle. So 1/4 of the children are sat in the circle. But on the next line, it tells us how many children are actually in the circle. So 1/4 of the children are in the circle. If 3/4 are in the stalls, you have a quarter in the circle. And then we're told that there's 117 children that are in the circle. So now if we piece these two bits together, this bit and that bit, we can now therefore say that therefore a quarter of the children in the circle must be these 117 children. So a quarter of all the children must be 117 of them. So 4 quarters make a whole. So if 1/4 of them is 117, if we multiply both sides by 4, that'll tell us the number of children. So the number of children must be 117 multiplied by 4, which we'll work out now. 117 multiplied by 4, that gives 468. So it's 468 children altogether. But we are told number of adults to number of children is 5:2. So adults to children is 5:2. Whoops, I'll do it in a different colour. So we're told this here. But we do know that the total number of children is 468. So how could we go from 2 up to 468? What have we multiplied 2 by to get 468? Well, we can work this out by simply doing 468 and dividing it by 2. So 468 divided by 2 gives us 234. So essentially we can multiply both sides of this ratio by 2, 3, 4. We do that to the same adult number as well. So 5 times 2, 3, 4. What does that give us? Let's see. 1170. So there must have been 1,170 adults and 468 children. So therefore, the total number of people must be these two values added together. So 1170 plus 468 gives us 1638. But we want to work out if there were more or less than 60% of the seats that were taken. So on this day, on the Saturday, were there people on more than 60% of the seats? So we need to work out the percentage of people that are sitting in the seats. So final step, percentage of people in seats. Well, there's 1,638 people divided by the total number of 2,600 seats. That's as a fraction. To go from a fraction to a percentage, you then multiply by 100. So we work out this fraction times by 100 and then compare that to the 60%. So 1638 over 2,600, all of that multiplied by 100, that gives us a total of 63%, which is more than the 60% of seats. Now this question is ultimately a yes or no. Were there more than 60% of seats taken or not? Well, there are people on 63% of the seats, which yes, is more than 60%. So therefore we conclude by saying yes. In other words, more than 60% of seats were taken. So just conclude, definitely say yes, and then say something like more than 60% of seats were taken. Or were used, words to that effect. And that's all we need to do for question number 2. So let's have a look at the next one. So for question 3, we've got a 3D shape, a prism with a cross-section in the shape of a trapezium like so. So the front of it and the back are trapezoidal. So the cross-section is a trapezium like it says. On this centimetre grid below, so each square is 1 centimetre, draw the front elevation and the side elevation of the prism. Use a scale of 2 centimetres to 1 metre. So what this means here is essentially for every metre we have, we do double the number of squares. So first of all, let's just consider, first off, the front elevation. So the front elevation just means looking from the front from this direction. So if we were looking head on, we'd only be able to see this trapezium here, which we're going to highlight in red on the outside. So here we'd see this shape and this shape only from the front. So we draw on this. So the front elevation would be this shape. So 2 meters, that's represented by 4 centimeters, 4 squares along. Half a meter is 1 square up. 2 meters is 4 squares going up. Then just join this point and that point with a straight line. So from the front, we'd see this yellow side, which is like this. We now need to do the side as well. So looking at the side from this direction here, we'd see this front face, where we'd see a little line as it sort of slopes inwards. But we'd also be able to perceive, we'd be able to see this slopey bit as well if we're looking at it from the side. So from the side, we'd see this rectangular bit, plus this bit too, which would also look rectangular. So what we'd see is this green rectangle here, which would be 2 cm by 1 cm on this centimetre grid. And then from 0.5 up to a full 2, so from 0.5 up to 2, that's another 1.5 metres in the vertical direction. We'd say this sky blue shaded area too. So it'd be 3 squares going up, 1.5 metres from 0.5 to 2, 1, 2, 3 squares, and it's still the same width as this 1 metre as well. So we'd see this blue and green like so. Question 4, we've got a speed, distance, time question. So Ollie drove from Liverpool to Manchester, then from Manchester to Sheffield. So it's going to be relating to speed, distance and time. So we're told that he drives 56 kilometres from Liverpool to Manchester. We're also told his average speed from Liverpool to Manchester is 70 kilometres. So we know the speed from Liverpool to Manchester, we know its distance. We can therefore work out the time it takes him to go from Liverpool to Manchester. Because we want to work out the time from Liverpool to Manchester, we just cover up the t for time. So cover up t for time. For Liverpool to Manchester, therefore, the time taken is the distance divided by the speed. So the distance, it took him 56 kilometres, and the time, so the speed was 70 kilometres. So 56 divided by 70, this will of course come out in hours. So 56 divided by 70, let's see what that gives us. So that gives 4/5, or 0.8 of an hour. And we might make more sense of this if this is in minutes. So how many minutes makes an hour? It's 60. So multiply this by 60 to get the answer in minutes. That makes more sense, perhaps. 48 minutes it takes from Liverpool to Manchester. But then, of course, he goes from Manchester to Sheffield. So what do we know about Manchester to Sheffield? Well, we know that the distance is 61 kilometres, so we know the distance. And it took him 75 minutes to go from Manchester to Sheffield. So we know the time as well. So we know the distance, we know the time, we don't know S. So for the part of the journey from Manchester to Sheffield, if we know D, T and want to work out S, we can now cover up what we want to find. We want to find S. So what's left tells us what to do. We need to do D divide by T. So for this bit now, the speed is the distance divided by the time. So the distance as we go from Manchester to Sheffield is 61 kilometres. And the time takes 75 minutes. So if we divide that 61 by the 75, that will tell us the average speed. But this will be coming out in kilometres per minute, because this time here is in minutes. So just be careful about the time units. So 61 divided by 75 gives us that. So it's about 0.813. And that speed, I've taken units of kilometres and divided by units which are in minutes. Now there's 60 minutes in each hour, so I need to multiply this speed by 60 to convert it into kilometres per hour. So this value multiplied by 60 gives a speed of 48.8 kilometres per hour. 48.8 kilometres per hour. So now what we can do is work out the average speed for total journey. So for part A, overall speed is going to be distance divided by time, so d total divided by t total. So the total distance, well, it goes 56 from Liverpool to Manchester, so that's 56 kilometres from Liverpool to Manchester. And then he also, for the journey from Manchester to Sheffield, we know that the distance was 61 kilometres, so 56 plus 61. And the total time, probably best keeping this in hours now, so the units come out exactly correct without having to change them. From Liverpool to Manchester, it was 0.8 of an hour. And then from Manchester to Sheffield, well, I could change this into hours straight away by doing 75 minutes divided by 60. 75 minutes divided by 60, that gives 1.25 hours. Not 1 hour 25 minutes, not that at all, but 1 1/4 hours. So if we type this in carefully, we'll have our solution. So it's 56 plus 61, all of that divided by 0.8 plus 1.25. Press equals, press S arrow D. We get 57.0-ish. Let's see how accurate we need to work out our answer. It doesn't say, so what we can do is use a golden rule of 3 significant figures. So 57, and that 0 will round up to a 7. Sorry, that 0 round up to a 1 because it's got 7 next to it. So it's 57.1 kilometres per hour. That's the final answer for part A. For part B, Janie drove from Barnsley to York. Average speed from Barnsley to Leeds was 80 kilometres per hour. Then from Leeds to York it was an average of 60. Janie says that the average speed from Barnsley to York can be found by working out the mean, the average, of 80 and 60. So she reckons that the overall speed between Barnsley and York would be the mean of 80 and 60, which would be 70. So if she's correct, what does that tell you about the two parts of her journey? So if you can average these out with equal weighting, what it's saying is she must have spent an equal amount of time going from Barnsley to York as she went, from Barnsley to Leeds, as she went from Leeds to York. So this part of the journey from Barnsley to Leeds must have been the same amount of time as from Leeds to York. So we just need to write something along these lines to secure the mark. So the time taken for both parts of her journey must have been the same. That's all we need to write. So that's question 4 boxed off. Number 5, we have two triangles, a smaller one sitting inside a bigger one, and ABC, this line, and EDC are straight lines, which just confirms that these are two triangles. EA, this line here, is parallel to DB, so we're going in the same directions, hence these arrows. So let's label on what we know. So we know that EC is 8.1, so let's label this on. So all the way from E to C is 8.1. From D to C is 5.4, so I can go on 2. And then from D to B is 2.6, so label this on. From D up to B is 2.6. Now let's just be thinking of this smaller one, DBC, the smaller triangle, compared to the bigger one, ACE. Well, they both share this angle C in common, and because AE and BD are parallel, this angle at D will be the same as this one at E, and this angle at A will be the same as this angle at B, again because these two are parallel. So all three angles in the big and small triangle are going to be the same. Obviously the triangles aren't the same size, but because all of the angles are the same, these triangles will be similar. And because of that, because they are mathematically similar, ACE, the bigger one, you can think of as being an enlargement of the smaller one, which is BCD. So all we need to think about is what the scale factor, the linear scale factor of enlargement is. So the scale factor, we take a side on the longer triangle and divide by a corresponding side on the smaller one. So we know the bases of each of them. So the longer base is 8.1, and the base on the shorter one on BCD is 5.4. So 8.1 divided by 5.4 will tell us the scale factor of enlargement. So let's see what this gives us. 8.1 divided by 5.4, that gives 1.5. So in other words, AEC is 1.5 times bigger than BCD. So from A to E is going to be 1.5 times bigger than BD. So therefore, AE is going to be 1.5 times BD. So that's going to be 1.5 multiplied by 2.6. And you can use your calculator on this if you want to. It's absolutely fine. That'll give you 3.9 centimeters. We're next told that AC is 6.15 and to work out the length of AB. So what we know here, because the scale factor is 1.5, we know therefore that the larger shape is 1.5 times bigger than the smaller triangle. In other words, for every unit of BC, from A to B is an extra half unit on top. So it's like a ratio of 0.5 ... 1. So in other words, so the full length is 1.5 compared to BC, which is 1. So we can do this as a ratio. So AB to BC is 0.5 ... 1. However, the total of AB added on to BC, that's the full length of AC. So AC are these two added together. So 0.5 plus 1 gives 1.5. However, we're told that AC is actually 6.15. So how can we go from 1.5 up to 6.15? What can we multiply by? Well, we can work this out by doing 6.15 divided by 1.5. So if we try that next, 6.15 divided by 1.5, that gives us 4.1. So we need to multiply all bits of this ratio relation by 4.1. So AB, we do 0.5 times 4.1. That gives us 2.05. So AB is 2.05. And 1 multiplied by 4.1 gives 4.1. But all we're being asked for here is the length of AB, which is this one here. So that must be 2.05 centimeters. I'll do this in a black colour instead. So AB is 2.05 cm. Question 6. Anil wants to invest £25,000, lucky him, for 3 years in a bank account. So you've got the personal bank, compound interest, 2% each year, and secure bank, which gives 4.3% for the first year, and then 0.9% for each extra year. What I'm going to do here, I'm going to convert these percentages into what I call decimal multipliers. So a decimal multiplier just means what decimal do I have, which I multiply the initial amount by each time 1 year goes past. way to think about it is like this. Before anything happens to an amount, you always start with 100% of itself. This personal bank, I'm adding on an extra 2%. So 100% plus 2% we can do here. So 100, shift, percentage button, plus 2, shift, percentage, gives 102%, but importantly as a decimal, it's 1.02. So this one here is 1.02. In exactly the same way, for the secure bank, 4.3%, that's going to be 1.043 as a decimal multiplier, and then 0.9%, that's going to be 1.009 as a decimal multiplier. So here's how we do it. So for personal bank, we take what he starts with, £25,000, and the total in his account at the end of 3 years, we're going to multiply by this decimal multiplier, 1.02, and because it's been invested for a total of 3 years, what we then do is we multiply this to the power of 3. So 25,000 times 1.02 cubed. And that gives us a value of £26,530, and I think it was 20p. Yes, 0.2. That 2 is 20. Whereas for the secure bank, again, similar procedure. We start with what the initial amount was, £25,000. However, this time, we only get this 4.3% rate for the first year. So we do 1.043 to the power 1, because we only get that rate for 1 year. And then after, we get 0.9% for the subsequent years. So the percentage, so decimal multiply in future is 1.009. So we've got 1.043 for 1 year. We're doing 3 years in total though, so we've got an extra 2 years at this rate. So we times that to the power 2. Then we see what we get when we compute all this. So this one is 25,000 multiplied by 1.043 to the power 1. You don't need to put power 1. Anything to the power 1 is just itself, but if you want to, you can, like I have. Then times by 1.009, and that's going to be to the power 2. Press equals, and we get £26,546. And then, to the nearest penny, 46p. Now it's just a case of comparing these two totals. Which one's better, which one's bigger? So all we need to answer here is which bank gives him the most interest at the end of 3 years. Well, we start with the same amount in each bank, so the one that gives him the most interest is just going to be the one which has the highest overall total at the end of these 3 years. We can see here that this personal bank account, which has 26,530, is a bit less than this one, which is 26,546. This has got an extra about £16 in this account. Therefore, this secure bank gives him the most interest. But you need to show this working in order to justify your answer. You can't just guess secure. This is the working needed. Then you say, therefore, secure bank gives the most interest. So really important we conclude by answering the question we were told to answer. So the actual answer is to say it's the secure bank that gives the most interest. And silly me, I've missed out the word most here. Secure bank gives the most interest. There we go. Question 7, we've got a number which is rounded to 2 decimal places. The result is 4.76. Using inequalities, write down the error interval for this number n. So it's going up in 2 decimal places. So let's imagine some numbers which have got 2 decimal places at the end of them. So 4.76 is a number in this list. So put 4.76 on a diagram you might want to. And then to the left of it, we're going to have 4.75, 4.74, 4.73, and so on. And going this way, it's going to be 4.77, 4.78, and so on. Something like this. So these are the values we'd have. 4.74, 4.75, going up in 2 decimal place lots. So after it's been rounded, it must round to 4.76. And so it's got to be closer to 4.76 than 4.75 or 4.77. So what we do is we find the critical points where it's exactly halfway in between these two. So when is it halfway in between 4.75 and 4.76? Where is it halfway in between 4.76 and 4.77? Obviously it's going to be here and there. So we're wanting our value for n to be in between these 2 dotted red lines. We want n to be in between 4.755 but no more than 4.765. So as an inequality, here's what we're going to have. So we're allowed to have n as 4.755. If it were that, it would round up to 4.76. Hence we have this can be equal to n. However, 4.765 is its absolute limit. It's not actually allowed to be that because, strictly speaking, if it were, it would have rounded up to 4.77. So it can be as close to this as you absolutely want to. It can be within a trillionth of that number without actually touching it. So it could be all the way up to, but not quite including, 4.765. So these are the absolute limits. That's the lower limit, which is allowed to be. This is the upper limit, which, strictly speaking, it is not allowed to be. But we get around that problem by not including the is equal part with this inequality symbol. So that works absolutely fine. That's the answer. Cumulative frequency graph. So here we've got the heights in centimetres of 60 students. We need to work out an estimate of a number of these students with a height greater, a height more than 160 centimetres. So what we can do here, we can read off at 160 on our grid. So read up and then along to find out the frequency of people that are at 160 centimetres. So go to 160, do a line up till we hit our curve, then go along and read off. So hopefully you can see here, this red line hits at a point of 48. That tells us that 48 people and fewer were 160 centimetres or shorter. So 48 students are that height or shorter, but for 60 students in total, that must mean the other 12, therefore, have to be taller. So therefore, based on that, we just need to do 60 take away 48. In other words, 12 students, therefore, are over 160. And that's our final answer. Number of students greater than 160 centimetres is just 12 students. Question 9, we've got some transformations to do. So we've got triangle A on a grid. So Kyle's going to do quite a lot of transformations with this one triangle. So first of all, he's going to reflect triangle A in the x-axis to get triangle B. So in the x-axis means it's going to be flipped here. So it's going to come from this place. It's going to be flipped. It's going to end up upside down, down here. So what we can do is just draw it in the lines. So this point here is 1 square away from the mirror line. It'll end up being 1 square away on the other side. This point is 3 squares away. So it ends up being 3 squares away on the other side, reflected, of course, perpendicularly. So first of all, B goes there. Afterwards, he then reflects B in the line y equals x to get triangle C. So the line y equals x is a straight line going through the origin, going through 1, 1, 2, 2, 3, 3, and so on. So this line in dotted blue is y equals x. So the mirror line is going to go from each point of B, going to hit this blue dotted line at 90 degrees. So the 3 lines from these 3 corners would look like this, going perpendicularly into that line, And then each point will end up being the same distance away from this mirror line on the other side. So for example, this point here is 1, 2, 3 squares away diagonally. It'll end up being 1, 2, 3 squares away over here. Same for this one, 1, 2, 3, 4, 3.5 squares away. It'll end up being a half, 1.5, 2.5, 3.5 way on the other side. So here's where the 3 points will be. Anything we need to do is to join these points up and to label that triangle C like so. So that's where triangle C is. What does she do next? Well, next she's going to reflect triangle A, this one here, in the line y equals x, which I've drawn on already, to get triangle D. So A is just going to be flipped to this point here. That point there will not move at all because it's already bang on the mirror line. So to get triangle D will end up being here. That's how it will be reflected in the line y equals x. Now, this image, this graphic is getting a bit too crowded, so I'm just going to take off a few bits and pieces now, just so it's not quite as overwhelming. So next we can think about what's going to happen in terms of this triangle D. She's going to reflect D in the x-axis to get triangle E. So the final thing is, this D, it's 4 squares up and away from x. Once it's reflected in the x-axis, it'll be 4 squares below and flip the other way around the other side of the x-axis. So it'll be reflected using these green dotted lines. It'll end up down here to be triangle E. So triangle E goes here. So Amy reckons that triangle E should be in the same position as triangle C. So E is over here, C is up there. Obviously not the same place at all. So is she correct? All you need to say, based on this information, based on your working, and your working is to do these translations and reflections correctly, this will do as your working. Then you can just simply say, no, Amy is not correct. As long as you've got these reflections in the right places, that is working enough for the examiner. Alternatively, what you could have said, you could have compared triangle A to C and E. You could have said, for example, she's not correct because to go from A to E is a 90-degree rotation about the origin of triangle A, whereas to go from A to C, that's actually a 90-degree rotation anti-clockwise, 90 degrees about the origin. I think that's going a bit above and beyond. That's making more work for yourself, in my opinion, although you could do it in terms of rotations. I think simply put, do A, B, C, D and E, show that C is in a completely different place to E, then just say, no, she's not right. Question 10, some standard form. Got some information about 8 planets. So write down the name of a planet with greatest mass. So with standard form, the bigger the power of 10, the larger the number is. So first of all, just compare the powers of 10. So Earth is times 10 to the 24. That's pretty big. 27, that's the biggest, and still the biggest going down. So the largest planet, the planet with the greatest mass, is Jupiter, because that power of 10 is the largest out of all of them. So the planet of greatest mass, Jupiter. Find the difference between the mass of Venus and the mass of Mercury. Well, the mass of Venus is this, and then the mass of Mercury is that. To find the difference, we just do one value, subtract the other. So do the big value, take away the small one. This is bigger because it has a higher power of 10. So this is going to be 4.869 times 10 to the 24 minus off 3.302 times 10 to the 23. So we can do this now using the calculator. I'd hate to do it without, to be honest. 4.869. Now, if there is a button on the calculator which can do it, or you can type it out the long, slow way. I prefer the long, slow way because it just looks better, in my opinion. So then times 10 to the power 24. Then I'm going to subtract from that 3.302 times 10 to the power 23. Press equals, and I get this here. So I get 4.5388 times 10 to the 24. Forgot what the numbers are already. 5388 times 10 to the 24 kilograms. So that's the difference in mass between these two planets. Next and finally for question 10, it says here that Nishat reckons Neptune is over 100 times further away from Earth than Venus is. Is she correct? Well, work out how you get your answer. So what we need to do here is to find out how many times greater one value is than another, we can simply do one value divided by another. So for example, 10 is 5 times bigger than 2, isn't it? 10 divided by 2 is 5. So that's how you find out how many times bigger something is than another. Do the big value divided by the smaller one. So here she's saying about the distance of Neptune. Neptune's distance is this, and she's saying that this is over 100 times further away from Earth than Venus is. The distance of Venus from Earth is 4.14 times 10 to the 7. So how many times greater Neptune is away? We can do 4.35 times 10 to the 9 divided by 4.14 times 10 to the 7. So let's see what this gives us. So again, calculators to the handy. I would not advise doing this without a calculator. So 4.35 times 10 to the power 9. All of that divided by 4.14 times 10 to the power 7. That gives about 105.07. So it's about 105 times further away. And ultimately 105 times further away is more than 100 times further away. But ultimately, the question here is just saying, is she right? Well, what was she saying to begin with? Well, she was saying that Neptune is over 100 times further away. We've shown it's 105.07 times further away, which is more than 100 times further away. So therefore, yes, she is correct. Or yes, Nishat is right, or Nishat is correct. Question 11. Solve this fairly horrible looking algebraic fraction equation. So because it's fairly horrible, because these questions aren't too popular with students, I'm going to show you two different ways for tackling this. So I'm going to set this out into two separate boxes, two separate methods. The first method I'm going to show you is more or less the standard method. Method A, just multiply through by the lowest common multiple of the denominators. So what is the lowest common multiple of 4, 3 and 6? The smallest number in each of these times tables is going to be 12. 12 is 4 times 3, 12 is 3 times 4, it's 6 times 2. So the lowest common multiple of the denominators is 12. So what we can do here, essentially, is just to multiply everything here by 12 on the top. So that becomes 12 lots of that bracket, divided by 4. That becomes minus 12 lots of 2x minus 5. And that's going to become 12 lots of 1 minus x. So what we're going to have here, when we do that 12 on top divided by the 4 on the bottom, 12 divided by 4 will give us 3. So the first fraction becomes 3 lots of 3x minus 2. Then we're minusing, important, minus. Now this 12 on the top, when I divide it by the 3 on the bottom, 12 divided by 3, I can simplify to 4 lots of a bracket. So 4 lots of 2x plus 5. And then here, this 12 lots of 1 minus x divided by 6, 12 divided by 6 just becomes overall 2 lots of that bracket. Now we just need to expand the brackets. So 3 times 3x is 9x, 3 times 2 is 6, so 3 times minus 2 is minus 6. Next, 4 times 2x is 8x, but that 4 is a negative 4, which will give us negative 8x. 4 times 5 is 20, but because again that's a minus 4, you get minus 20. Finally here, 2 times 1 is 2, 2 times minus x is minus 2x's. So now we just need to simplify down. So 9x take away 8x, that's just 1x. If I take away 6 and then take away another 20, that's the same as taking away 26 in total. Over here, I've still got 2 minus 2x. The suggestion I have now is always to get all the x's onto one side of the equation. So I can get rid of these negative 2x's by adding 2x's to make them vanish. If I add 2x over here though, I need to do the same on this side as well. So on the left, x plus 2x gives me 3x. Still have that minus 26. Over here, those minus 2x's have vanished. I've still got 2. I need to get rid of this minus 26, so I can add 26 to that side. And if I do that to that side, I must do the same over here. So then I get that 3x's must be 2 plus 26, which is 28. Therefore, x must be 28 divided by 3. So 28 divided by 3 is that. Or you can press Shift and then S arrow D to give it as a mixed number. What I wouldn't do is give it as an infinitely recurring decimal. If you're having to do that, put the dot above to show it's recurring. Do not just write 9.3, that is a mistake. The easiest bet I think is to leave it as 28 thirds or 9 1/3. So x equals 28, or you could say 9 1/3. So that's probably the most standard method for doing that. Whoops, I mean say 28 over 3. That is important, that could have been a bit of a mess. So 28 over 3, my apologies, that needs to say 28 over 3, like that. So, the other method, if you don't like multiplying through or you find this a bit of a mess, what you can do is actually leave the denominators there. So method B, get the denominators to all be the same thing, and then just ignore or focus on the numerators. So using this method, what we're going to do, if I just clear this away now, I want all the denominators to be the same, and in the same way as before, I can get the denominators to be 12. So what I can do here, I could times the 4 by 3, and then do the same to the top. So this one, if I triple the top, I get 9x minus 6, and triple 4 gives me 12. This one here, to go from 3 up to 12, I can multiply by 4. There, do the same to the top as well, times all of this top by 4. So importantly, it's a minus, so stick a minus in, and times all these things on top by 4. 2x times 4 is 8x. 5 times 4 is 20. And on the bottom, 3 times 4 is 12. Then over here, to go from 6 to 12, I can just double the 6. If I double the bottom, I have to double the top as well. So over here, I'm then going to get 6 times 2, which is 12. And double 1 is 2. Double minus x is minus 2x. I can then combine these underneath the same denominator as I could for any fraction. So 9x take away 8x is just 1x. Minus 6 minus another 20 is minus 26, and that's all over 12, equals 2 minus 2x over 12. Now think what we've got one fraction as being equal to the other. Not only that though, but we can see clearly one fraction is equal to the other. If the bottoms of these fractions are the same, but both fractions are equal to each other, it stands to reason the only way that can be is if the tops are also equal to one another. So x minus 26 has to be the same as 2 minus 2x. And that's your way into doing it without really having to multiply through by everything. You might find this method easier, you might find it a pain. If you don't like it, just use method A. But we've got x minus 26 equals 2 minus 2x. It now becomes the same as before. We've got the same now as this line here. So if we add 2x to both sides, we'd get 3x minus 26 equals 2. Add 26 to both sides, 3x must be 2 plus 26, which is 28. Therefore, x must be 28 over 3, like before. Or like before, we can give it as a mixed number and say it's 9 1/3. So whichever method you prefer, use the way that makes more sense to you. Question 12. We've got 30 students in Mr. Lear's class. 16 students are boys. 2 students from the class are chosen at random, and Mr. Lear draws a probability tree diagram for this information. Write down one thing that's wrong with the probabilities in the probability tree diagram. So where to begin here? Well, we just need one thing that's wrong. So what we could say here is these denominators for the first student are out of 30. That's fine. But then if 2 students are being picked, then this second number should be 29, because once one student's been picked, they can't be picked again, so there's only another 29 to choose from. And so what we can say here is that this denominator here needs to be 29. Another thing we could say is that if we look at these 2 branches here, they should always add up to 1. 15 over 30 plus 13 over 30 doesn't equal a whole unit. That gives us 29 over 30. Same here. So we could either say these ones I've circled in red don't add up to 1, or you could just say that the second denominators need to be 29 and not 30. So either denominators for second student should be 29, or you could say the probabilities for the second student don't add up to 1. The next part of this, part B. Owen and Wasim play for the school football team. The chance that Owen scores a goal in the next match is 0.4, but the chance that Wasim scores a goal in the next match is 0.25. Mr. Slater reckons that the probability that both boys will score a goal in the next match is 0.4 plus 0.25. Is he right? Give a reason for your answer. Well, the chance of one boy scoring and then the other boy scoring too, if one happens and then the other scores, and means we multiply the probabilities. If 2 things happen together, we have to multiply the probabilities, not add them. So ultimately he's wrong. Something like this would be enough to secure the mark. No, he's not right, because the probabilities should be multiplied together, not added. It should be 0.4 times 0.25, not 0.4 plus 0.25. Question 13 is a histogram. So it's information about the ages of 134 members of a sports club. 20% of the members of the sports club who are over 50 years of age are female. So let's think about what bit of the histogram represents those people 50 or over. So 50 years or over is going to be all the data to the right of this red dotted line. All these bits in yellow I'm going to highlight here. So all these people in these yellow boxes represent the total people over 50. We can come to this percentage of the 50 years or older people in a moment. So how do you work out the frequency, the total number of people from a histogram? How does that relate to the frequency density and the width of these bars? You need to know this relation. You need to know that frequency density equals the frequency divided by class width. Fat dads feast on chicken wings is my stupid way of remembering it, yet it works for me. So, for this slice of the first bar over here, we can work out the frequency for this one by doing F equals the frequency density of that bar multiplied by the class width of that bar or portion of the bar. So for this one here, the frequency density comes up to 1.4, and the class width of this portion of the bar, this is at 50 and goes to 60, so that's a width of 10. So 1.4 times 10 gives 14. And then for this one, same idea, frequency density multiplied by class width. This one's got a height of 0.5, 0.6, 0.7, so frequency density here is 0.7, and the class width, it goes from 60 all the way up to 90. From 60 to 90, that's a width of 30. So 0.7 times 30, that's 21. So in total, for people over 50 years of age, I've got 14 from this first slice of the bar, plus 21 here. So for total people over 51, so total over 50 years, is 14 plus 21, which is 35 people. Now 20% of these people that are over 50 years of age are female. So we need to work out 20% of the number of people over 50 years of age. In other words, we need to find 20% of 35 people. So 20% of 35. So 20 shift percentage of, press multiply, 35. That gives us 7. So there must be 7 females over the age of 50. And that's our solution for number 13. So we've got some graphs for question 14, and it's just a case of matching the correct equation to the correct letter of a graph. So some we can work out easier than others, but I'll just run through these with you. So the graph of sine x. So what we need to do here is know that when x is 0, sine of 0 is 0. We need to know as well it's going to be a wave, so it's going to be either C or D. But if you just check on a calculator that sine of 0 is 0, you know it's got to go through the origin. So the only wavy one going through the origin is graph C, therefore the sin x graph has to be graph C. The next one, x cubed plus 4x. Again, what you could do with a good enough calculator is just to actually try this one using a plot. So I'll just show you how to do this one now. If you go to menu and then option 3 for table, you can type in your function using this f of x button. This just means y, essentially. So read this as y equals. So I want an x, so alpha, then press an x, which is the right bracket, shift right bracket, cube that, plus 4 lots of x. G of x is another graph if you want it. I don't want that, I'm going to put that as equal to 0. So x goes negative as well, so let's try, I don't know, from -5 up to +5. The step just means what x is going up by each time. So this means x is going up in 1. So if I press equals there, and you can see here when x is negative, y is very, very negative. When x is 0, I go to 0. So I have to go through the origin as well, this one. So I can eliminate a lot of them by knowing that most don't go through the origin. So it's either f or g. C's already been taken. But then as x goes bigger, you can see here using this plot, as x gets bigger, the values of y go very, very big indeed. 80, 145. So y is going really, really fast when x gets bigger. It looks like graph f, and in fact it is graph f. You can do this table function for all of these functions if you want to. In the same way, y equals 2 to the x. What you'd find for that one is that matches to graph A. As x goes more and more negative, it gets close to 0, but never goes negative. When x gets very big, 2 to the power of something big is absolutely humongous. So that's graph A. Finally, y equals 4 over x. If you do 4 and divide it by something very, very tiny, the answer comes out to be very, very big indeed. So what we're wanting for this one is when x is very, very small, y is very, very big. And also when x is very, very big, 4 divided by something very, very big gives us an answer which is very, very small. So it's going to be this one for h. You get the similar idea as well when x is negative. When x is negative, you get this curve here. And so that's going to be graph h. So in the order, we've got C, F, A, H. Question 15 is a good old circle theorem question. So A, B, C and D are all points on the circumference. AEC and BED are straight lines. We have to prove that triangle ABE and DCE are similar. So ABE I'm going to highlight in red, DCE I'm going to highlight in blue. Here they are. So I need to show that these two are similar. To show triangles are similar, I just need to show clearly that all three angles in these triangles are the same. So I think the easiest place to start, going back to year 8, year 9, these here are called vertical opposite angles. So this angle here at E is the same as that one because these make an X angle. The fancy word for X angles is vertical opposite. So to get the marks, what we'd say is that angle AEB is the same as angle DEC. And give the reasons, because it does say to give reasons. If you don't give the reasons, you lose marks. So the reason is that vertically opposite angles are equal. So I've shown that one of these angles in each triangle is the same. Next, we need another circle theorem. So if I now imagine the chord AD and the angles which are coming from this chord. So from AD, I've got this angle here at B, from that triangle here, and I've got this angle at C as we go from A to C and back to D. Now it's a circle theorem that tells us that this angle here at B will be the same as this one here at C. And the circle theorem for that, you need to know, is called angles in the same segment are equal. The way I think of it is if you've got two angles that are standing on the same chord, they'll always be equal, as long as these angles go towards the circumference, that is. So both of these greens are both stood on AD, therefore they're both the same. We use the same theorem now, but come in from the opposite direction and think about this chord BC. So this chord here, BC, we've got this angle at A stood on it, and this angle at D stood on it as well, like so. So again, this angle at A will be the same as this angle at D. So to give it its proper names, this is angle EAB, always a middle letter. That's the same as angle EDC, as we go from E to D to C. And again, the same reason, using the same circle theorem, angles in the same segment are equal. So we've shown that pink is equal to pink, green is equal to green, yellow is equal to yellow. Therefore, these two triangles have three identical sets of three identical angles for different size triangles, but the same angles within them. Therefore, we can say that ABE and DCE, because they have three angles the same, they have to be mathematically similar. That's all we need to do for question 15, so we can move on to number 16. Number 16, what we have to do here is to use algebra to prove that 0.136 recurring multiplied by 0.2 recurring is equal in value to 1 over 33. So at least you know what you're aiming for, you know what the answer is. It's just a case of getting to that point and showing it clearly and algebraically, which is the point of the question really. So I'm going to show how to do this in a fairly standard way, which is hopefully familiar or familiar-ish to what you may have seen before. If not, let me know. So I'm going to split these two values into two different letters. So what I'm going to suggest we do is we just call one of them X and call the other one, well, call it Y. So let X be 0.136 recurring. I'll explain what this is in a moment. And let Y equal 0.2 recurring. So what I'm going to do here actually, I'm going to just colour code the X in terms of red, and I'm going to colour code the Y in terms of blue. So what I'm going to do first of all, I'm going to write down, first off, X down here. So if I write what X is, then I can say that X is, and then I'm just going to make sure the decimals line up perfectly, because this is really, really important. I'm going to put a decimal point here. So 1x is going to be 0.136 recurring. So it's going to be 136, 36, 36, and so on and so on. That's what the recurring means. You don't need to do 1,000,001 of these columns I'm doing, but just a few to show the examiner that you understand the concept of what a recurring decimal is. We then multiply this value by powers of 10 until we get these digits in these columns lining up. So if I multiply by 10 and do the next bit above, what would 10x's be? Well, if I take this and multiply by 10, then you can even do this in a calculator if you wanted, but 0.136 recurring, in fact I'll show you. So what we need here is to type in the value 0.136 recurring. So we type in the 0.1 because these parts of a decimal aren't recurring. The recurring part we type in by pressing Shift then the x squared button on this particular Casio. So Shift then x squared gives this button here for recurring, then we just type in all of the recurring block. So 3 and 6 are both recurring, so we type in 3 and 6, then press equals. We get obviously 3 over 22, but if you press S arrow D, and again if you need to, it shows you the setup, just as we wrote out longhand. So if I multiply this by 10, I get 1.36 recurring, which is 1.36, 36, 36, 36, and that 4 is the 3 which is rounded up to a 4 by the 6 at the end. So it's 1.36 going on forever. So we can fill in 10x now. So 10x is just 1.363636. So as you can see as I'm writing it, these digits in the columns do not line up at all. Where there's a 3, there's a 6 above. Where there's a 6, there's a 3 above it. So these numbers are totally out of line. So we multiply by 10 again and keep going until the numbers in one of these rows are in line. So take 10x times by 10 again to get 100x. Make sure the decimal is still in line. So we take this and times by 10 again. Do it on your calculator if you want to. This 10x times by 10, 1.3636 times by 10. This decimal moves to the right one, so 1.3 becomes 13. And then after the 3, the first digit is going to be a 6. Then comes a 3, then a 6, then a 3, and so on. Now, if we have a look at this, you should hopefully see that the top line and the bottom one I've done do in fact line up. This one here is in line with that one there. So therefore what I can do is I do the very top 100x, take away 99x, so I take away 1x, and that gives me what 99x's are. So 99x will equal, well, if we do the top row take away the bottom one, then this cancels, it all cancels up to a point, which is what we want to happen. We want to go from something recurring to something that is not. 6 cancels with 6, 3 cancels with 3, but now it doesn't cancel. So 13.6, take away 0.1 is 13.5. At this stage now, I can think about actually just saying and proving what x is. So therefore x must be 13.5 divided by 99. 13.5 over 99. Let's see what that gives us. So 13.5 divided by 99. That gives us 3 over 22, which the calculator showed us. And so x is 3 over 22. We now do the same idea for y. So y is 0.2 recurring. So if I write down 1y here, that's going to be 0.2 recurring. 0.2 going on forever. We now need to multiply this by 10 and see what happens, if the numbers are in line or not. So if I multiply this row by 10 to get 10y, and if I multiply a decimal by 10, it just has the effect of moving this decimal to the right one digit. So we get now 2.222 going on forever. So you can see here that the columns already line up perfectly. So you can go straight away and do one column to take away the other. to get what 9y would be. So if I do 10y, take away 1y, that gives me 9y. Then over here, this will all cancel off, which is what I want. 2 take away 2 cancels. So this is all going to cancel up to a point, of course, until I get down to this point. 2 take away 0 leaves me with exactly 2. So 9y equals 2. So therefore, y equals 2 divided by 9. So 0.136, which is x, I got was 3/22, and this 0.2 recurring, I've proven, is 2/9. So from this, we can now conclude by saying, therefore, 0.136 recurring multiplied by 0.2 recurring is one and the same thing as 3/22, because that is 0.136, which we've proven, multiplied by 0.2 recurring, which is 2/9. This is a show that or prove that question, so do take an extra bit of care with your working. Don't shortcut or scrape with any working out method. So 3 times 2, top times top, gives us 6. And then 22 times 9, just to prove to examiner you're not just overly relying on your calculator, 22 multiplied by 9, 198. So show them that you're doing this as a fraction, which can then be simplified. Then 6 over 198, fingers crossed this will simplify to what we need it to. 6 over 198, divide both top and bottom by 6, we do indeed get 1/33, which is what we wanted to prove all along anyway. So that's it proven, therefore we've sorted out question 16 and it's done. Question 17 looks probably a bit worse than it is. We've got ONQ, which is a sector of a circle with centre 0 and radius 11. So let's add on the information as we go. So the radius of this sector, which is a slice taken from the middle, the radius is 11. And so from O to Q is 11, and from O to N is 11 too. It then says that AOB, that white triangle coming out from the centre, is equilateral sides 7 centimetres. So all the sides of this white triangle here are going to be 7 centimetres. Let's add that information on. As well as that, if it's an equilateral triangle, each of the angles will be 60 degrees, as well as all these sides being 7 centimetres. We have to calculate the area of the shaded region as a percentage of the area of the sector ONQ. Give your answer correct to 1 decimal place. So first of all, just thinking about this triangle here and how we can get that shaded region only based off the sector, the triangle and the whole thing. So essentially this sector, which is shaded, ANQB, is the whole of the sector with this triangle taken away. If I were to just scrub out that triangle, take it off, you'd be left with that shaded area. So it's the area of the sector minus the area of this triangle. But how do you work out the area of a triangle if it's not right angled? Well, we can use this formula here, which again, ideally you need to know. The area of a triangle for any angle is half times one side times another, multiplied by sine of the angle in between them. So we can now work out what we need. So we want the shaded area as a percentage of the area of the sector ONQ. So we're wanting to work out this first of all. A sector, you need to think of it as a slice of a circle. So we're talking about areas. If it were a full circle, which I know it's not, how do you calculate the area of a circle? Well, the area of a circle is obviously pi r squared. So if this were a full circle, the area of this full circle would be pi multiplied by its radius squared, which would be pi times 11 squared. However, you're probably thinking, but it's not a whole circle. You're quite right. We need to think of this as a fraction of a full circle. So this angle here is 60 degrees because it's an equilateral triangle. So out of a full 360, this is just 60 degrees out of the full 360 that would make the circle. So I'm wanting this fraction of pi r squared. Basically, it's just 1/6, if it's simplified down. I want 1/6 of pi r squared. So I work this out. I'm going to take away the area of this triangle AOB. Area of a triangle is half times one side times the other. So that's half times 7 times 7. If that's 7, then this one here is 7 as well. Times sine of the angle in between them two sides. Well, between that 7 and that 7, I know it's going to be 60. So, quite a big calculation to do, so type it in very carefully indeed. So, step by step, this one here, it's 60 degrees out of a full 360. So it's at a fraction of shift pi times the radius of 11 squared. Then I'm going to subtract away the area of this triangle, which is 1/2 multiplied by 7 multiplied by another 7 multiplied by the sine of the angle in between those two sides. Close brackets, press equals. We get 42.1378. That isn't a final answer, so I'll give a few more digits. 2945. And that's the shaded region. So what we've worked out here is essentially just the shaded region, which is the sector minus a triangle. So the shaded region is that. But I want the shaded region as a percentage of the area of the sector ONQ. So the sector ONQ is actually the whole thing here, which is a calculation for full area, is this. So if I want the shaded region as a percentage of sector ONQ, I need to do the shaded region, first of all, as a fraction of sector ONQ. So I need to give a shaded region as a fraction of the sector, shaded out of ONQ, get it as a fraction, then to change from a fraction to a percentage, I then multiply by 100. So the shaded area, we can work out, well, we have worked it out in fact. So this shaded area is 42.13782945, and the sector ONQ is this formula here, which if we want to, we can just work this out. So that's going to be 60 over 360 multiplied by shift pi times 11 squared. So we get here about 63.355. And the other digits, because I keep forgetting, which is annoying, 45185. So it's those two values in the fraction multiplied by 100 to convert to the percentages, which is what I'm actually after. So what I can do here, because I've got the denominator, I can basically cheat and just type in ANS. So my previously stored answer at the bottom is what I want. The top is this grey number, 42.137. 82945. And times all of this by 100. Can actually get it right. There we go, times by 100. I get here to one decimal place a value of 66.5. So my answer is 66.5%. And that's all we need to do for that one. Question 18, we've got here an awful looking thing. Work out the exact value of x from this equation. The key spot here is, look at the base values, 16, 2 and 8. All of these are powers of 2. So what I need to do here is to convert them all into powers of 2. It's just a case of spotting this from experience. If that were, like, say, 3, that were 9, that were 27, I'd be saying the same thing about convert them into powers of 3. So I'm just going to do this one number at a time. So 16 to the power 1/5. I'm just going to rewrite 16 as 2 to the power 4, because 2 to the power 4 is 16. So I'm going to rewrite 16 like so, but of course it had a power by it. It's a power 1/5. That's been times by 2 to the x. 2 is already as a power of 2, so that can be left as it is. But 8 doesn't look anything like 2. So 8, again, I could write as a power of 2. 2 multiplied by what gives 8? Well, it's going to be 2 cubed, because 2 cubed is 8. So that's the first step, and it's a crucial step. Without that step, you're going to be absolutely snookered. So we've got this. Now what we do is we apply the laws of powers. So here, whoops, that was a mistake. We've got here power 4 to the power 1/5. Power of a power, we multiply the two little numbers together. So 4 times a 5th, that becomes just 4/5 as an overall power. Times that by 2 to the x. And this one here, same idea, 2 to the power 3 to the power 3/4. To do the power of a power, I multiply this one by that one. So 3 multiplied by 3/4 is actually 9/4. One final rule we need to know for indices is when the base values are the same, which these are now if they're all base 2, now I'm doing one power multiplying by another power, I can simply add these little powers together on top of the same base. So as a single power of 2, I can just add together 4/5 and x. So 4/5 plus x equals 2 to the power 9/4. So it's an equation, obviously, one side's equal to the other. Now you can clearly see that the bases are the same, one side's equal to the other. If the bases are the same and both sides are equal, then it stands to reason that the powers have to be the same as well to make it work. So in other words, 4/5 plus x equals 9/4. So therefore, 4/5 plus x equals 9/4. I can then rearrange this. I can take 4/5 from both sides to get x on its own. So then therefore x is going to be 9/4 minus 4/5, which we can just do with a calculator now if we want to. Do it without a calculator if you really want to. I wouldn't recommend that if it's a calculator paper, like this one is. 9/4 minus 4/5, press equals. We get 29/20, which is absolutely fine. Or we could say 1.45. So we got 29/20. Or instead, you could have said 1.45. That would be perfectly acceptable as well. So two different possible answers really. Either's fine, whichever makes more sense to you. 29/20 or 1.45. Question 19, the dreaded algebraic fractions again. So we need to show that this awful looking fraction mix can be written as a single fraction in this form, ax plus b over x squared minus 9, where a and b are integers. Work out the value of a and the value of b. So weirdly, you don't actually have to do the fraction, although essentially I suppose you do, to work out what a and b are in this expression ax plus b. So I'm just going to write the fraction out as it is, all these fractions. So I've got x plus 2 over x minus 3 minus x minus 6 all over x plus 3. So to take one fraction plus or minus another and combine it into a single fraction, you need to remember that the denominators have to be the same. X minus 3 and x plus 3 are not the same, but what I could do, I could multiply each of these denominators by the other one. So here, I could multiply the bottom by x plus 3, and to keep it equivalent, I could do the same up to the top. So times that by x plus 3 as well. This one over here, I could times that by x minus 3 on the bottom. Times that by x minus 3 on the bottom, I'll do the same with the top to keep it as an equivalent fraction. Now here's the trick. These here are all fractions. That's a fraction, 2 isn't. So what I can do, I can rethink of what 2 is as a fraction. I can rewrite any whole number as a fraction by writing it over 1. So I'm going to rewrite 2 as 2 over 1. These denominators are going to both become x minus 3 times x plus 3. This here, this unit 1, has been multiplied by neither. So what I need to do over here, to get these both to x plus 3 and x minus 3, I need to times both top and bottom by this 2 over 1, by both of these denominators, not just one. So times by x plus 3 on the top and bottom, and by x minus 3. Now, x plus 3 multiplied by x minus 3. I'm just going to show you this quickly. This is called a difference of two squares, and if you've forgotten it, this is a lightning speed whirlwind tour of how it works. I'm not going to go into this in any great depth because hopefully you should know a bit about this if you've done your revision. But if not, as I say, I'll throw you a bone here. So imagine what would happen if I multiplied out x plus 3 by x minus 3. So expand it out using this grid. So I'd have x multiplied by x, which is x squared. X times by 3 gives me 3x, but x times by minus 3 gives minus 3x. Finally, this box, 3 times minus 3, gives minus 9. And as you can see, this positive 3x will cancel with a minus 3x, so we'll have, after all of that, just simply x squared minus 9. Which is hence what we have here, this x squared minus 9. So we can neaten this up a lot now. So this fraction here, I'm going to rewrite this as 2 lots of x plus 3 brackets x minus 3. But I've just shown you here, hopefully, that x plus 3 times by x minus 3 gives us x squared minus 9. So on the top of this first one, I'll have 2 lots of x squared minus 9. 1 times this, x plus 3 times x minus 3. That'll just give me on the bottom x squared minus 9. This one, we'll combine them together in a moment. So I'm timesing x minus 3 by x plus 3, which again will give me the x squared minus 9 on the denominator. On the top, I'm going to have x plus 2 times by x plus 3. So the top is going to become x plus 2 multiplied by x plus 3. So I can do this now. So x plus 2 times x plus 3. And this one, again, we're going to have x plus 3 multiplied by x minus from the bottom. So again, the denominator there will become x squared minus 9, which is what we wanted. We wanted the denominators to become the same, so we can combine them, which we'll do soon. The top, we're taking the x minus 6 and multiplying that by the x minus 3. So now we can expand these out, and then we can begin to think about combining them very soon. So first of all, this one here becomes 2x squared minus 18. So I get 2x squared minus 18 all over x squared minus 9. This one here we can expand out again in the same way, and I'm going to do this a fairly quick way just so I'm not lingering. Slow down the video or just try it yourself if you're not sure, but x times x, expand this out, you get x squared. X times 3 is 3x, x times 2 is 2x, that gives me plus 5x, and then 2 times 3 is 6. Now, all of this is being subtracted, so if it helps you to remember, think of this all in big brackets. That's all over x squared minus 9, of course. And finally, the last fraction, again, is over x squared minus 9. If I were to expand this one out here, x minus 6 multiplied by x minus 3, that's going to give x squared, x times minus 3 is minus 3x, x times minus 6 is minus 6x, minus 3x minus another 6x is minus 9x. But then finally, what I'm going to do here is minus 6 times by minus 3, which gives me positive 18. So again, what I can do is think of this all in big brackets, and now we can very carefully think about combining all of this into the same common denominator all over x squared minus 9. Taking particular care with the negative signs. So first of all, this one is just 2x squared minus 18. That's easy enough. Now I'm subtracting away all of this. So I'm taking away a normal x squared, so that's just minus an x squared. I'm now subtracting positive 5x. If I take away normal 5x, that's just minus 5x. I'm now taking away a normal 6, so that's minus 6. Over here, I'm taking away an x squared, so I minus off x squared. Then I take away a minus 9x. Minus 9x means I need to add on that 9x. Finally, take away a normal positive 18, that's just minus 18. Now here what we can do is do some simplifying and cancelling. These two x squareds here, just so happens we're taking away one of the x squareds here and the other one there. So that's going to completely cancel off with the x squareds. The rest of it is just simplifying out. So the bottom of the fraction we can leave as x squared minus 9 because the question gives it to us in that form. And over here, let's see how many x's we have overall. So we've got minus 5x plus 9x. Overall, that gives us 4x's. So that gives 4x. And then the constant term on its own, if I take away 18, minus 6, and minus another 18, let's see what that gives us. So minus 18, minus 6, minus another 18, that gives us minus 42. But what did the question ask us? Just be very careful. The question asked us, if I scroll back up, a and b. So a is the number in front of the x, b is the number on its own at the top of the fraction. So the number in front of the x is a 4, so therefore a is 4, and b, this number on its own, is a negative 42. So a is 4, and b is minus 42. Question 20, we've got a diagram showing part of the quadratic curve y equals x squared minus 2x plus 3. Part A, it says, by drawing suitable straight line, use your graph to find estimates for the solutions of x squared minus 3x minus 1 equals 0. So what we need to do is to compare this curve to the equation we've actually got. Okay, so to go from x squared minus 3x minus 1 and compare that to the actual curve we've got here, I need to actually add on an extra x because that's only minus 2x, and minusing 3x is away here. I need to actually add on an x to both sides. That'll then give me x squared minus 2x's minus 1 equals x. So this is looking a bit closer to y. I've got the x squared matching, the minus 2x's are matching, but here the graph of y equals this quadratic curve, it needs to have plus 3. Currently I've got minus 1. So what do I need to add on to minus 1 to get to positive 3? Well, I need to add 4. And if I add 4 to the left, I must add 4 to the right. So x squared minus 2x minus 1 plus 4 gives me 3 overall, which is what I want. And that's x plus 4. So now I've got this to match how I wanted. So that's the yellow curve, like so. So I can see when the yellow meets this one, which I'll colour code in green. So what I can do is draw the graph of y equals x plus 4, and where that graph coincides with the yellow quadratic curve, that's going to be where the equations are equal. That's going to be the solution to x squared minus 3x minus 1 equals 0. Don't be thinking you can just do the quadratic formula on your calculator for this. You could, but it does say by drawing a suitable straight line. So you could check your accuracy after using the formula, that's fine. But for now we need to draw the straight line y equals x plus 4. So it's going to be a straight line. It's going to cut the y-axis intercept at 4 because of this 4 like so. So I can just mark off here like that. And for every 1 unit we go along for x, y goes up by 1 unit because it's a gradient of 1. Think of it as being a y equals 1x. So if I go along 2 units for y, so 2 units for x, y would go up 2 units as well. So along 2, up 2. Then this one, along 2, up 2, along 2, up 2, and so on. And so the curve, so the straight line y equals x minus 4 is going to be a straight line like this. And just to make it clear, I can highlight this in the green, because I'm trying to find where the green hits the yellow. So that's the line we've got. So next up, what we need to do is to actually think about where these hit each other. So these two intersect at this point here. So if I just drop a line down and think about what that value is, and also over here, if I drop a line down and think about this value here too, that will tell us what our solutions should be. So what values of x do we need to read off? Well, each little square here is worth 0.2. 0.2, 0.4, 0.8, 0.6, 1, 1.2, 1.4, 1.6, 1.82. So if each little square is 0.2, that's 1.5 squares in the negative direction. So 1.5 times 0.2 give me 0.3. So one solution is that x equals minus 0.3. Because that one there is about minus 0.3. And over here, 2.2, 0.4, 0.6, 0.8, 3, 3.2. That's halfway between 3.2 and 3.4. So I'm going to go for 3.3. So x equals minus 0.3 and 3.3. So those are our estimates based off drawing this accurately. What I would suggest is know how to do the quadratic formula. Check that your answers are close to the exact by using the quadratic formula, and if not, and if you've got time at the end of the exam, rub out your wrong line and think, well, how can I get the answer to make what it needs to? How can I draw my line on differently? So you might be able to find a way of working backwards to get the right answer, but that's how you draw the line. Anyway, part B. P is a point on the graph of y equals x squared minus 2x plus 3, where x equals 2. Calculate an estimate for the gradient of the graph at the point P. So what we need to do here, we need to draw a tangent where the graph has a value of x being equal to 2. We have to draw a tangent, and here's one I made earlier. So when x is 2, y is 3 here. So if you just, to draw a tangent, a line that just scrapes the curve at that point there, what you should find is that you have a straight line. This red line is the tangent to the curve at that point. Now yours doesn't have to be a carbon copy of mine. The examiner gives what's called tolerance in case your line is a bit wonky or not quite perfect. I'm not saying mine is either, okay? But don't worry about it. As long as you've got evidence of trying to draw a straight line but just scrapes a curve at that point, you're okay to proceed. So the gradient, m, is just the change in y divided by the change in x between any 2 points you know on this line. So that red point here, that's when x is 2 by my reckoning and y is 3. So I can take that point and use it. This point here is 2 along and 3 up. I can take as well another point of my choosing. I'm going to pick this top right one here. So that point is 6 along, and if that's 10, that must be 11. So it's 6 along and 11 up. So I'm going to base my gradient off this point here and off this point here. So between these 2 points, the change in y is 11 take away 3, and the change in x between my 2 points, yours will be different, but you should get a similar answer to mine. The change in x was 6 here, but it used to be 2 there. In other words, x has gone along 4 units, which is 6 minus 2. 11 take 3 is 8. 6 take away 2 is 4. 8 divided by 4 gives a gradient of 2, and yours should be fairly similar to 2, if not exactly. You need to have a gradient between about 1.5 and 2.5 to secure the marks. So as long as you've got an answer that rounds to 2 to the nearest whole number, you should be fine for that. And that's question 20 done. For question 21, we've got a diagram to have a look at and solve. So we've got 3 identical circles inside a rectangle as shown. So each circle touches the other 2 circles, and the sides of a rectangle, again as shown. The radius of each circle is 24 millimeters, and we have to find the area of the complete outer rectangle enclosing these circles. Give your answer to 3 significant figures. So let's just piece this together and add on the information as we can on this diagram. So the main bit of information we're told is the radius of each one is 24 millimeters, and they're all identical. So we can label on these radii as follows. So that's 24, that's 24, 24 and 24. So we know that the total length all the way across this rectangle will be 24 times by 4, which will be 96. As well as that, we need to think about the width of a rectangle as well. Now this is going to be the nub of the question. This is what we need to be really trying to solve. So we know this radius here is 24 and this one down here will be 24. So we can add those in. But we're missing this middle length here. We don't know what that is. So like I said here, we can add on that these are 24 and that's 24. The question's going to hinge on how to work out this missing bit here. So what do we know? Well, what we could do is from the center of each circle, we can join these together using a triangle in yellow like this, and then we can think about what the lengths of each side of this triangle are. Well, from the center to where this circle touches is 24, then from the edge to that center again is a radius. The radius is 24. So 24 plus 24, that side's 48. That side and that side is 24 plus 24, so that's 48. And the top edge, as you can see, is 48. So this triangle, all the sides are 48 centimeters, so this yellow triangle is going to be equilateral. So if I add on these dimensions like so, and we can think about it being an equilateral triangle, we also need to know that the angles inside an equilateral triangle are all 60 degrees. So we're going to use that bit of information right now. So if I just enlarge this triangle and pop it here at the bottom left, we can add on some more information and begin to solve it. If we find out the length of this dotted red line will relate to this space here. So if I work this out, I can work out this missing piece, then I'll have the full length and the width, then I can work out the area like I had to do all along. Because this is an equilateral triangle, what I can do here, I can just add on that one of these angles is 60 degrees, because, well, it's an equilateral triangle, isn't it? So if I just call that 60 degrees, I need to find this dotted red line. So actually, I can think of this as being a right-angled triangle and avoid this other half of it. So I can actually just nicely ignore this bit, just cover it all up like so. So if I cover that up, what I've done here is essentially I've halved this top edge. It used to be 48 all across. half of that's now 24. So I know that side's 24. I know that the hypotenuse is 48. I just want to know the length of this one here. So I can either do trigonometry or I could do Pythagoras. It's actually up to you. Either way around you do it. I'm going to go for Pythagoras, by the way. We get here that the shorter side squared plus the other shorter side squared, this one here, call it question mark squared, will always equal this longest side all squared. So if I subtract 24 squared from both sides, that'll give me what the question mark squared is all on its own. So the question mark, the side I'm trying to find all squared, is going to be 48 squared minus 24 squared. If you want to, you can work this out now. So 24 squared, so 48 squared minus 24 squared, that gives us an answer of 1728. So therefore, this side here, the question mark, is going to be the square root of all of that. So the square root of 1728. So if I just square root this answer now, square root my answer, I get that it's 24 root 3. So I can add this on to this one here. So that side, I've now worked out, that side here is 24 root 3. So we can now work out the area of the rectangle. So therefore, the area is going to be the base times the height, or the length times width, whichever way around you want to do it. Length times width. So the total length of this rectangle, hopefully you can see, it's just all this going along. So that's 96. And the width, or the height of it, is going to be the sum of all these numbers here added together into 1. So the total width, and put this all in brackets because we don't know what this is as a single value, so it's 24 plus 24 plus this final bit we worked out was 24 root 3. So if we type this in carefully, we'll get our correct solution with any luck. So 96 multiplied by, open brackets, 24 plus 24, you could just put 48 if you wanted to, of course, plus 24 lots of root 3, close the brackets, that gives us a value of 8598. 8598, and it carries on 645 and so on and so on. Now let's just check how accurate we need our answer to be. We want our answer to be to 3 significant figures. So we need to keep 1, 2, 3. So our answer is either going to look like 859, or if it were to round up, it would look like 860. Now, because next to the 9 is an 8, that 859 will round up to 860. But to keep it the right size, we need to change that 8 here to a 0. So it's going to be 8,600 millimeters squared to 3 significant figures. The 859 rounds up to 860, and that 8 we change to a 0 to keep the number the correct approximate size. The final answer here is 8,600 square millimeters. Question 22. We got 5 terms of a sequence here, so 4, 11, 22, 37 and 56. Find an expression in terms of n for the nth term of this sequence. So I'm just going to give myself a bit more space, so I apologise. Just going to take this bit out here. We need to find the nth term of this sequence. So let's see what this sequence is going up in for each number. So from 7 to 11, it's gone up by 7. From 11 to 22, it's gone up by 11, then 15, and finally from 37 to 56, it's gone up by 19. So it's not a arithmetic sequence because the gaps aren't the same. However, if we work out the gaps of the gaps, you'll see here that all the gaps of the gaps, as it were, are the same, therefore. So if the gaps are going bigger, or different should I say, but the gaps of the gaps are the same, this is a clue that it's a quadratic sequence. So it's a quadratic sequence we're going to try to find here. And the general form for a quadratic sequence is an squared plus bn plus c, where n is the number in that sequence, the first number or the second number, and so on. So what I'll do here, I'll just do a table and call n at the top and the term at the bottom. So that's the first number, so that's when n is 1, that's when n is 2, that's when n is 3, 4, 5. This procedure can be used for all quadratics to find the nth term of a quadratic. Your teacher may have mentioned it different to you. If so, maybe just ask them or follow this method through and get mastery with this method. Anyway, what we're going to do here is we just pick the first three terms. So when n is 1, when n is 2, and when n is 3. So first of all, we're going to do when n is 1, n is 2, then n is 3. So when n is 1, we just plug in the value of 1 in place of n. So an squared just becomes a, because a times 1 squared just means a times 1, which is a. B times n becomes b times 1, which is just b. And c is just going to be c. So when n is 1, the term of the sequence is 4. And it is 4 because that's the first term. So n is 1, that's the first term. So the first term is 4, so we can just highlight that as so. We then do the same idea when n is 2. When n is 2, that's the second number, which is 11. So we take this expression for what the nth term is and plug in n as having a value of 2. So when n is 2, a n squared becomes a multiplied by 2 squared. But 2 squared is 4, so a times 2 squared becomes 4a. When n is 2, bn becomes b multiplied by 2, which is 2b, and of course c is just c again. And the final one, when n is 3, we just substitute in when n has a value of 3, and we get here the third term, which is 22. So when n is 3, we substitute that in again to the an squared plus bn plus c expression. When n is 3, a times n squared becomes a times 3 squared, which is a times 9, which is 9a. bn becomes b times 3, which is 3b. And of course, again, c is just c on its own. So you get 3 different sets of equations. Doing it this method, it's always pretty much the same setup. So what we do next is very procedural. What we do, we make 2 lots of simultaneous equations from the middle and the top, and from the middle one and the bottom one. So at the top and the middle, I want to keep the numbers positive because positive numbers are just easier. I'm going to do the middle equation, take away the top one. So 4a take away 1a gives me 3a. 2b take away 1b leaves me with 1b. c take away c vanishes. And the value at the end, 11 minus 4, gives me 7. The same here, when I do the bottom equation, take away this middle one, I'm going to get 9a take away 4a, which is 5a, 3b take away 2b, which is just 1b again, and like before, c take away c will cancel, so that's just going to leave me with 22 take away 11, which is 11. We then do the same again, this time, again to avoid any negative numbers if possible, I'm going to do this bottom equation, take away the top one. So 5a take away 3a gives me 2a. The b's cancel. I'll then have 11 take away 7, which is 4. So I now know that 2a equals 4. So therefore a must equal 2. So I now know from this one that this a has a value of 2. Once I've got that, I then substitute this back in to one of the earlier equations, one of these two here. So which one you pick, it's entirely your choice, to be fair. I'm going to go for this one here. So you put this back into there, and when we do that, we're going to get that 3 lots of A, which in other words is going to be 3 lots of 2, because A is 2 we've worked out, plus B equals 7. So we just have to simplify this to work out what B is. Well, 3 times 2 is 6, so 6 plus B is 7. 6 add what gives us 7? It has to be 1, doesn't it? Because 6 plus 1 works. So therefore B has to be equal to 1. Based off that, we then can put the values of A and B back into one of the very starting equations. So my suggestion would be here to pick the very first equation, this one. So now I know what A is. A is 2, plus B, B is 1, so plus B means plus 1, plus C equals 4. And just to recap, all I've done there is use the value of A and the value of B, which we've just calculated. So what would C have to be to make this work? Well, fairly obviously, 2 add 1 is 3, 3 plus something is 4, so therefore C again would also have to be equal to 1. So therefore, the nth term for this one, all we need to do now is plug in our values for A, B and C into this original generic expression. So we now know that A is 2, we know B is 1, and as well as that we also know that C is 1 as well. So putting these values in, we have an squared is 2n squared, because A is 2. Bn becomes just 1 times n, because B is 1. 1 times n is just n. And C is 1, so plus C, we just write plus 1. And that's it, we're done. So the nth term for this quadratic is 2n squared plus n plus 1. Finally, the very last question on this entire paper. So we're told here that L is a circle with equation x squared plus y squared equals 4. Now, before we move on with this, we need to just remember the equation of a circle for GCSE. This will be an equation centered upon the origin, and that 4 is the square of the radius. So the radius of this circle is actually the square root of this number at the end. The square root of 4 is 2. So that's going to be a circle centered at the origin with radius 2. So I would suggest for this one to sketch on the diagram. So x and y, centered on the origin, radius of 2. So it's going to cross the axes at a point 2 away from the origin, like so. Next, we're told that this is a point on a line, the circular line L. So we can add this on, again, on our sketch. So P is a point which is about 1.5 along and root 7 over 2 up. So P is going to be somewhere here. Just sketch it on as you can. Something like this would do. There it goes. Then label on the x and y coordinates, like so. We need to find an equation of a tangent to L at the point P. Well, a tangent just scrapes the curve. So the tangent's going to be going in this direction, going down. What we can do for a circle, the most obvious line of a circle, is of course its radius. So what I can do here is think about how steep that radius is. To put it technically, what's the gradient of that blue radius line? Well, we need to know that the gradient is a change in y divided by the change in x. So the gradient of this radius is the change in the y coordinates between the origin and there, divided by the change in x coordinates between the origin and here. So the change in y, it goes from 0 up to root 7 over 2. So the change in y is just root 7 over 2. And in the same way, the change in x is just going to be 3 over 2, which is 1.5 if you wanted. So we need to do root 7 over 2 divided by 3 over 2. Now this here is one fraction divided by another. You could do this on your calculator in fairness. It doesn't matter if you just button bashed it and it came out correctly. But just to recap, a fraction divided by another, we keep the first thing, change the divide to a times, flip 3 over 2 on its head to give it 2 over 3. Then if we do this on the calculator or not, you should find that you get root 7 over 3. So just showing you on a calculator what this would look like, you just typing it in the easy way, root 7 over 2, then we needed to divide that by 3 over 2. That would have got root 7 over 3, which is obviously what we wanted to show. So what do we do now? Well, we know that the gradient of radius is root 7 over 3, so how can this help us? So what we need to do now is be thinking of this tangent. It's crucial at this stage to remember how the radius meets the tangent, in other words, what angle they meet at. The radius and the tangent will always meet at a perpendicular angle. They always meet at 90 degrees. Another throw off from that is that the gradient of any tangent is the negative reciprocal of the radius it meets at the circumference. And so if the gradient of a radius is root 7 over 3, then the gradient of this green tangent will be this fraction turned on its head and made negative. So in other words, the gradient of a tangent will therefore be minus 3 divided by root 7. That fraction's been flipped on its head and the positive has been made into a minus. We can now think about putting together the equation of this tangent. So the equation of a tangent is a straight line, so I'm going to refer to the standard equation of any straight line, y equals mx plus c, where m is the gradient of a tangent, but we know that's minus 3 over root 7. So y is m x plus c. We don't know what c is. We need to find what c actually might be. So what other information do we know about this tangent? Well, we can substitute in an extra point we know, because we know that the point P is on that tangent. So we can sub in that when x is 3 over 2, y is root 7 over 2. We're just substituting in the points from P. So basically subbing in P here. So y we put down as root 7 over 2. So y root 7 over 2 equals the gradient minus 3 over root 7 multiplied by x. So if x is root 3 over 2, that's going to be, 3 over 2, it's going to be like this, then plus c. So all we need to do here is make this a bit neater. So what I've got here is root 7 over 2. So minus 3 over root 7 times 3 over 2. Let's work this out. So minus 3 over root 7 and times 3 over 2. Whoops. There we go, that's better. Times 3 over 2. That gives us a value of 9 root 7 over 14, minus 9 root 7 over 14 rather. I then need to add this awkward looking value to both sides, so if I add on 9 root 7 over 14 to both sides, then I'll have what c is. So therefore c is going to be root 7 over 2 plus this answer here. So it's going to be root 7 over 2, so root 7 over 2. Then I'm going to add on 9 lots of root 7 all over 14. And that'll give me a value of 8 root 7 over 7. I've now got the equation for L. So L, I can write it down now, so L has the equation y equals, got the gradient from before, minus 3 over root 7 times by x plus c, which is 8 root 7 all over 7. or any equivalent form to that one. That's what L is. That's the final question done, therefore the whole paper's been complete. So thank you for bearing with me through that. I hope you found some of the questions I've gone through useful. If you're still unsure, feel free to leave me a comment on the comment section. Please do consider liking and subscribing, that's always rather nice. And stay in touch very soon for the next video in the series. Until then, it's goodbye from Mr. Bailey. Take care of yourselves, study hard, and hope to see and hear from you all very soon. So goodbye and be in touch.